All right, everybody. It's a great day for your boy J-Cal. I am still long Uber. I still have a large amount of holdings, and the stock was up massively today because they had record high free cash flow and they beat on revenue.
This Week in Startups is brought to you by QuickNode gives blockchain developers unparalleled reliability and speed with access to unlimited endpoints across 18 chains and 35 networks. Get 1 month free by using code TWIST at go.quicknode.com/twist. CacheFly is a pure play CDN provider that makes CDN simple, effective, and secure. Deliver content faster than your competitors and get 10 terabytes free forever if you sign up at twist.cachefly.com. And the Microsoft for Startups Founders Hub helps all founders build a better startup at a lower cost from day one. Startups get up to $150,000 in Azure credits, access to free OpenAI credits, free dev tools like GitHub, technical advisory, access to mentors and experts, and so much more. There is no funding requirement, and it only takes minutes to join. Sign up today at aka.ms/thisweekinstartups.
This is a great day for me. You can see I'm very enthused. My net worth went up, but also the bet I placed over a decade ago that defined my career as an investor. I always believed this company would start becoming a money printing machine, and thus that has happened. Q1 revenue, $8.8 billion. That's up 29% year over year. And we're talking about cloud computing. I had Alex on last week, and we're talking about, it's falling to single digits. Well, it's not falling to single digits. Uber, up 29% year over year. Revenue came in $100 million above analyst estimates, according to CNBC. The total trips in Q1, 2.1 billion. I remember when Uber had a total of 3 riders on the platform, and we'd done maybe a dozen rides, up 24% year over year. That's incredible. And this includes mobility and delivery. Monthly active platform customers, MAPs. There's no way to pronounce MAPSes. Actually, MAPSes works. Monthly active platform customers. This is Uber's sort of MAUs, monthly active users. But what they want to say is these are customers who are active on the platform, not dormant accounts, ones that actually did something. That was 130 million. That is extraordinary. We're talking 9 figures worth of customers monthly. And looking at the revenue, 72% revenue growth for mobility, 23% year over year for delivery. And freight, the freight business dropped 23% year over year. I'm not sure what the details are there. We'll double click on it in a future episode. Can't win them all. 2 out of 3 ain't bad, but that's a small number. It's an emerging business for them that they're investing in. Total gross bookings, right? This is the top line before they give a large percentage of the money they make to the drivers, and the drivers are doing spectacular. That's why so many people are driving for Uber. Don't believe the fake news, which keeps saying like Uber drivers are making $8 or $9 an hour. That's all made up nonsense. The truth is they're making $25, $35 an hour, and the gross bookings were 31.4 billion, up 19% year over year. So, the revenue grew 29% year over year, but gross bookings grew only 19%, which means Uber's, more profitable and charging more for their services. Just great to see. Bottom line, they had a small net loss of 157 million, and that included a $320 million benefit from net unrealized gains related to Uber's equity investments. But really, cash flow, that's what matters, right? How much cash makes it into the coffers, as we say. And this excludes capital expenditures, right? So you'll have some things on the books that are capital expenditures, but the actual amount of cash into the business, so this is accounting issues. Record high free cash flow, $549 million. Cash and cash equivalents and short-term investments, $4.2 billion for the team over at Uber. And I think the really interesting part of all this is Lyft's demise. They are a shrinking amount of this industry, and Uber, I don't want to say has a monopoly because it's not a monopoly. You have DoorDash out there, you have Lyft out there. You have people competing like public transportation and micro-mobility, and people owning their own cars, rent-a-cars, and taxi and livery drivers, right? So to say Uber has a monopoly, or they don't, on mobility, nor do they have it on delivery. What they have is they have the majority now of app-driven rides, and they have a strong presence. I think they're number 2 in the United States behind DoorDash in delivering groceries and food. But people order from other sources as well, right? There's still Instacart. You still have Amazon delivering groceries and Whole Foods. So it's not quite a monopoly, but it's a strong position in those areas. And the average Mapsy did 14 rides or food orders in the quarter. That's almost 5 per month, which is very impressive because you take the 2.1 billion trips and you divide it by 150 million, Mapsies. Just taking a guess here that maybe they're taking 14 rides or food orders in the quarter, which would be about 5 per month. That's the average. Now, that means there's people who use Uber a lot. There's people who drop in, but if you're like me, I'm using Uber Eats and taking Uber rides at least 10 times, 15 times a month. So I think I'm probably in the 40 or 50 a quarter, 200 a year kind of group as a family. Because, man, my daughters love to, they get me every time. Oh, we did our homework. Can we get boba? Or, can we order sushi? And I'm a sucker because I just take it out and I'm just like, you know what? I want you to have a great childhood and enjoy some nice sushi and some boba. So just to Dara and the team, and Dara's coming on the show over the summer. We'll have a great interview and catch up. But the stock is ripping. It's up almost 11% today, which puts me in a great mood. Not just because money, which is nice, but I got enough of that. It's just about being right and betting on a team and really seeing the investment come to fruition. And this year at Founder University, I'll make somewhere between 50 and 100 25K investments as a tribute to that 25K investment I made in Uber as one of the first investors, maybe the third or fourth. I don't know. So if you want $25,000 from me to start your company, get 2 or 3 founders, have one technical person, make an MVP, come to founder.university, hang out with me. We're going to actually have our own space in San Mateo soon. And just come hang out with JCal. Let me give you that lucky 25K first check so you can incorporate. Maybe come to our accelerator, the Launch Accelerator. We'll give you $100,000 and let us syndicate you on the syndicate.com. Share it with other angel investors and get you a milli or 2. I think the average is like $700K to the syndicate. So it's been an amazing journey with Uber as my best investment in history. And I'm trying to hit another one or a bigger one. And so that's not going to be easy. But in the next 10 years, I hope to invest in maybe 200 or 300 names per year, which would put me at 2,000 more investments in my second decade of investing to go with the 300 in my first, or 250 in my first decade. I'm going to 10x that. And, you never know. Maybe I hit another Uber or 2, and maybe that's you. So founder.university or launch.co/apply to meet with our team. Great job, Team Uber. All right, next up on the program, Charles Fisher, the CEO of Unlearn.AI. Okay, everybody, all of the complaints about building apps on the blockchain. It's slow. Oh, it's less reliable. Oh, there's no support if things go wrong, right? The blockchain is this incredible innovation. And there's some good news here. Execution on the blockchain just got super easy. QuickNode has solved all of these problems. They give blockchain developers unparalleled reliability and speed with access to unlimited endpoints across 18 chains and 35 networks. QuickNode provides amazing response time and a dedicated 24/7 customer support team. They offer consistent performance at any scale, lightning fast API responses that are 2.5x faster on average than competitors, and the most sophisticated and globally balanced cloud and bare metal Web3 architecture. Listen, everybody, this is the AWS or Azure of Web3. If you are building dApps, decentralized apps, you need to use QuickNode. It's that simple. Find out why companies like Twitter, Adobe, Coinbase, and OpenSea use QuickNode. Get 1 month free by using the code TWIST at go.quicknode.com/twist. That's go.quicknode.com/twist. And remember to use the code TWIST. All right, everybody, welcome back to our special AI series. Never seen anything move this fast in the 30 years I've been in the technology business. So we are having people on the program 3-4 times a week here at This Week in Startups to share what they're working on and why, so that we can all keep up with this crazy pace. We found an interesting guest today. His name is Charles Fisher. He's the founder and CEO of Unlearn.AI, Unlearn.AI. And he is taking AI models to try to speed up clinical trials for pharma companies, which seems like a really interesting idea, Charles, and welcome to the program, but also one that has me a bit concerned because using ChatGPT 3.54 and some of the other tools, Bard from Google and the Quora AI tool, they're frequently hallucinating and giving wrong data. So maybe we could start with a little bit of how long you've been working on this, and then getting right to how this is going to change clinical trials and the hallucination problem.
Yeah, definitely. So thanks for having me. How long have I been working on this? That's a really interesting question. I think how long have I been working on like generative modeling as an area? Because I was an academic researcher before starting Unlearn. So I don't know, like 15 years probably since I've been working on sort of generative AI. But we've been at this with Unlearn now for about 6 years, not quite, almost 6 years, working on, developing generative AI to currently speed up problems in clinical trials. So like, let's make clinical trials biggest bottleneck. We want to make that faster, but eventually we want to roll this out to think about how we can really sort of revolutionize the way we think about medicine, turning all of medicine from something that's really today kind of an art form into a real predictive science that's founded on computer science.
So let's talk about what is a clinical trial. What is the, state of the art architecture of that? Because I don't invest in this area, but some of my contemporaries do, and they talk about how incredibly frustrating and humbling it is to beat the placebo, as I've been told, which is placebos seem to work 10% of the time, 15% of the time. They have some efficacy that is not zero. It's in some cases pretty amazing what the placebo can do to people's minds in terms of having an impact versus actually having an impact. So maybe the definition of in 2023, what is a clinical trial? How does it work today? And then how is your software going to change that?
Mm-hmm. A clinical trial is simply a comparison. So it's the same thing as an A/B test that you would run in any other area. So I have some new experimental treatment, and I want to compare that to usually what is currently available. So placebo usually doesn't mean that you get no treatment at all, usually given whatever you would normally get for that particular disease plus a placebo. So you're still receiving some treatment. And I just want to know which of these two things is better, which is safer, which works better, like so forth. Typically, clinical trials are staged out. And so we have 3 different phases. Phase 1 is usually done in around 10 or so, often healthy people. You give them your experimental drug. You just increase the dose until you see too high of dose. and then that lets you figure out how much is like a safe dosage. Then after that, you move on to a phase 2 trial. That's usually like around 100 people. And this is just an early signal of, does this seem like a drug that is worth continuing to pursue? And then the last thing would be a large phase 3 clinical trial. That's usually around 1,000 people. And here you're going to randomly assign half of the people to receive your new experimental treatment. You're going to randomly assign the other half to receive the control. And then at the end of the trial, you're going to compare, see if it was better or worse. And then you can submit those data to the regulators like FDA to help them make a decision about whether or not your drug should be marketed.
Got it. And so that process, I've heard a lot of criticism of that process. Objectively, what are the criticisms of that process? And then we'll get on to sort of what you're doing.
There are a million criticisms of the process.
The major ones, that are valid.
Yeah, right. So the first thing that I think we tend to encounter is just the amount of time and cost that goes into running one of these trials. One of these big phase 3 clinical trials, just the individual trial itself can cost hundreds of millions of dollars to run. and they often take more than 5 years, right? So you're talking about spending 5+ years on a single experiment and hundreds of millions of dollars. And most of the time, these trials fail. So the majority of time, actually only about 10% of drugs that enter clinical trials end up being successful. So 90% failure rate in clinical trials. So
Wow.
You're spending like a decade and hundreds of millions of dollars on an experiment with a 90% failure rate.
And would that mean if 1 out of 10 actually work, we're talking about billions of dollars to get a successful drug to market if you were to look at it as a portfolio of, say, 10 drugs?
That's right. Yeah. Yeah. So incredibly expensive, incredibly time consuming. I think that there are other things in terms of like, we need to get participants to be willing to join and take part in these clinical trials. And then you get into other issues of, certainly issues like placebo control are controversial amongst like patient advocates. Why is it that you're participating typically in a clinical trial? Usually that's because you want access to this new experimental therapy. So I think that what people are thinking about, and certainly what we're thinking about, are ways that we can leverage new technologies to alleviate these problems of the speed and cost of clinical trials, but also align them more closely with what patients want.
Got it. So how are you using AI machine learning to test drugs? Because it would seem to me that the human body is complex in many ways, in other ways, probably very simple. And interactions are hard. So are you literally running a simulation of, hey, here is this new drug for, I don't know, lowering your cholesterol. And you can model the human body and how it would interact? And does this occur in parallel to phase 1, 2, and 3? Or is this something that is just run in a simulation that informs how you would then run these different trials? Explain to the audience how this works.
Sure. So, like I said, every clinical trial is a comparison. And what we really want to know is, for an individual person, we wish we could tell, like, what would happen to this person if I could take them and I gave them this new experimental drug and I observe how they respond. And I simultaneously don't give them the drug and I observe how they respond, right? And so the way to run that experiment is to invent a time machine. So you give them the drug, you take your time machine back in time to the point you did it, and then you don't give it to them and you see what happens, right? And you do this comparison. We don't have a time machine, but we do have computer models. And so the whole idea kind of behind what we do is that what we're going to do is, for every individual person in a trial, we create a digital twin of that person. And it's a computer model that allows us to simulate what would happen to that individual person. And in our case, in the trials, we're always simulating what would happen if they got the control. So we don't simulate what would happen if they got this brand new experimental treatment, only what would happen if they got the existing treatment. And the reason is, brand new experimental treatment is not really a machine learning problem, right? Like machine learning, we learn from data and we make new predictions, right? So what we can do is we'll have data from like 100,000 patients receiving the current treatment. And then what our task is, given a new patient, how will they respond to this current treatment? And that's kind of a standard machine learning problem, as opposed to, here's a brand new molecule. What will it do to a person? That's much harder. Yeah.
So if I were to reflect this back to you in simple, plain old English,
it wasn't simple enough.
Well, I'm going to even try to simplify it for me. Explain it to me like I'm a 5-year-old kind of situation here. We have 100,000 people who have taken this current cholesterol lowering drug.
Right.
You're in the new trial. You're going to get cholesterol lowering drug 2.0. It's completely new. And then there's people who are going to get the placebo. But hey, since we know these 100,000 people's age, cholesterol level, BMI, heart rate, whatever battery of information, we can say, hey, JCal, 52-year-old JCal, 174 pounds, this blood pressure, this cardio fitness level, whatever it happens to be. We take your watch data. I don't know what data is state of the art these days. And, okay, yeah, look, we have another, out of those 100,000 people, we do have 2,000 people who are just like JCal. We're going to run a simulation to see what would happen with you on the 1.0 medicine. You're going to take the 2.0, and of course, we've got some other group of people who are taking the placebo. Is that about right? What's happening?
Yeah, I mean, well, yes. So we're taking this data from the people that currently exist. We're training this kind of machine learning model on that data. Yeah, and then exactly. So we would predict JCal comes in. We'd say, what would happen to you if you got the placebo and version 1.0 cholesterol medicine? And so the interesting thing is, if you take that to the extreme, and let's imagine this case where that machine learning model we've built is perfect, makes no mistakes at all. That's not true, but let's just imagine.
If it's 50% correct, it's going to have an extraordinary impact. So
right, yeah. But this interesting scenario, which you can kind of work backwards from, is, well, if that were very true, then for every patient, I can just give them the new 2.0 cholesterol medicine, and I can see how they respond to it. And I don't need I would not need any real patients receiving a placebo. Because for every patient, I'm just predicting exactly perfectly what would happen if they got a placebo. So if you could sort of get to that point where our machine learning models are sufficiently accurate, you get to a world in which you're running clinical trials that don't have placebo groups. It would be 100% of the patients receiving your new experimental treatment and 0 patients receiving a placebo. So that would mean you'd have a clinical trial that's got half as many patients in it, which is way faster and cheaper to run. Also, all of your patients are getting access to this new experimental treatment, which is what they wanted, right? So that future is really great for our customers, the pharma companies, because they get faster trials. Actually great for all of medical research, because you basically speed up medical research twice as fast. It's also great for patients. It's not perfectly achievable because our models aren't perfect today. And so then we get into this question about how we still run randomized studies where some patients receive placebos to guard against what you were calling earlier with hallucinations, right? Yeah. So we want to make sure that we can guarantee that the clinical trials that we work in produce the right results, even if our models are not perfect.
It seems to me that when a new drug comes out, depending on the corpus of data you have about individuals, you could give it a shot and say to the AI, hey, make your best predictions and give me, they're depending on compute power available, give me all the possible predictions you could come up with in some reasonable amount that a human could actually compare them and say, predict what will happen with these 2,000 people who are joining the trial as best you can, and then give them the trial and then see which sets of thinking the AI got correct. That's also a possibility and would also cost nothing, because all you're doing is saying, just make a simulation. It'd be like running a simulation on who's going to win the NBA finals based on the data you have from the regular season. Is anybody doing that as well? Because it seems like it could be a worthy use of time.
Yeah, I mean, right. So what we are basically doing, again, is we're simulating how every single patient in this trial is going to respond if they got the new treatment. We are very interested as well into, as drugs come out, incorporating. So this is kind of the future world. So the way I kind of view it, interestingly, is that clinical trials are a highly regulated area, super scientifically rigorous, right? But we think they're the easiest area, actually. They're easier than all of the other areas of medicine. And the reason for this is because treatments are randomly assigned to patients. So basically, the way that this will work is that the model will make mistakes. It will make those mistakes on patients who are randomly assigned to receive the placebo. And it makes the same mistakes on the patients randomly assigned to receive the treatment. And basically, in the end, the mistakes end up canceling out. Right. And so because of that, it's like that particular application is really robust to these mistakes that machine learning models make today.
Listen, everybody, when it comes to the blocking and tackling of running your startup, you don't need to reinvent the wheel. CDNs, aka content delivery networks, are the place where startups can really overcomplicate things. You don't need custom authentications or custom codes. No. If you're a startup, you need to just check out CacheFly. It's a pure play CDN. And CDNs are literally all they do. So they're the best in the world at it. They've been doing it for over 2 decades. That's 20 years. CacheFly makes CDNs simple, effective, and secure. Let me say that one more time. Simple, secure, effective. Effective, secure, simple. Simple, effective, secure. you eventually are going to outgrow the smaller ones that are trying to give you too many discounts. You want the best of breed. So don't burn your startup credits using a CDN at one of those larger players. Let CacheFly handle it all for you. They will help you deliver your content faster than your competitors. You have to be fast if you want to compete, whether it's videos, your mobile app, games, content, SaaS. The faster you go with your delivery, the more people will use your product. So go check out CacheFly. And Twist listeners are going to get 10 terabytes free forever when you sign up at twist.cachefly.com. That's twist.cachefly.com. 10 terabytes are waiting for you for free. Stop what you're doing, pause the podcast, go to twist.cachefly.com and get your 10 terabytes for free forever. Talk about the data. Well, the thing I'm curious about is the data that is currently used for these trials.
Mm-hmm.
My understanding is one of the problems is garbage in, garbage out. You get information from patients. If they tell you information, well, how many drinks do you have a week?
Sure.
They're like 2, and it's really 20. Or, so if they're reporting data, it's obviously going to be flawed. And then if you look at the data that's available in medical records, well, why do we even have medical records today? It's for billing, right? It has nothing to do with, or it has more to do, am I correct, with billing than it does with reality?
100%.
Is that right? Yeah.
Yeah.
So what data do we actually have that has some truth to it? It feels like wearables, are perhaps the holy grail. Blood tests, you can't fake those. I don't believe. You can tell me if I'm wrong, but blood tests that are historical, maybe body scans, which I just did the Pronovo body scan, and wearables. If I gave you my Fitbit data for 10 years and then my Apple Watch, which I switched to, all of those seem to be that's pretty rock solid. So are any of those type of things being currently used in these trials, or is it still just they go to people's medical records and they give them a survey to fill out?
Well, clinical trials are a really unique space when it comes to data and medicine because it's a research study. So one of the problems with medical records, if you looked at my medical records, you would see that I've been to the doctor 4 times in the last 20 years, right? And all of the information in between those dates is just not even there. Because I didn't go to the doctor, so it's gone. It doesn't exist, right? But a clinical trial is really different. So in a trial, it's set up ahead of time, and you define this giant battery of exams that you're going to give to patients. And that always includes things like blood tests. Now it includes other new things. There are times where it's going to be wearables. Sometimes it's going to be imaging. Maybe people are getting MRIs. It could be full genomic tests, you might get a whole genome sequence potentially. So it could be a huge amount of information. It varies from trial to trial, but everyone is going to get this giant battery of tests. And then they're going to come in once a month for the next year and a half. And they're going to make that same battery of tests every month. So regardless of what happens to them, whether or not they're feeling good or they're feeling bad, it doesn't make any difference. You enroll in the study and you come in once a month and you get this giant battery of tests. So there's actually a huge amount of information about, these diseases that is being captured in these clinical trials. So this is an opportunity in 2 ways. First of all, we run tons of clinical trials every year. As a society, we run a ton of them. Actually, the government runs a ton of them. The NIH funds a ton of clinical trials. And all of those data just poof out of, they're collected and they're not used again. They're just poof.
What? So literally you have this incredible diamond mine in a clinical study. They collect all the diamonds and then they just throw them in the dumpster.
They don't exactly get, but they put them in a database somewhere.
It's the end of Indiana Jones and Raiders of the Lost Ark. Exactly. It goes into some warehouse.
That's right. Yeah, the top men are working on it. Exactly. It's it's in some warehouse and it's never used again.
Oh. How do we... Now, hold on a second. Let's pause there for a second. If this is paid for by the government in a lot of cases, the government owns it.
So, there's a rule that you have to make the data public 2 years after your clinical trial has been completed if it was funded by the government.
So that is sitting on a server somewhere, or is it a public website?
There's no government server where it exists that's all put together. So we have a group of people. So we aggregate data from lots of sources to train from. And we love clinical trial data because it's this high quality, amazing data sets. So like we have a group of people who like call up professors at universities and are like, hey, you ran this clinical trial 2 years ago, so the data must be public now. And then we aggregate the data. Yeah. It's crazy
so it's
to
like
me
a
the government
Freedom of
doesn't do it.
Information Act, like people will do in journalism, this Freedom of Information Act, say, hey, listen, the government arrested this person, there are documents available, JFK assassination, give us the information, the government will release some percentage of it or whatever. You can actually start going and getting this information.
Yes.
And then putting it into AI models. This is something that we should have a Manhattan Project on, where some organization is paid, like yours or another, it could be private sector, public sector collaboration, to make a database of anonymized data of every clinical trial that's gone on. And then you could just set the AI on it.
100%. I 100% agree. Yeah. And right now, the other part of it is the industry sponsored trials. So there are pharma companies who are running all of these trials.
Mm.
They own the data from those trials. So that's typically how that
makes sense. They paid for it. Yeah.
One could argue that maybe the patients should own their own data, potentially, but
individually they should.
Yeah, they don't, but that's another point.
They really don't. They don't own a dual license to it.
No, in many cases they're not given it at all. Yeah.
See, that's something that
some patients never find out whether or not they got the placebo or the real drug.
Okay, so this is somewhere where like our government's not going to get this done because they're bought and paid for by pharma. I said that, not you. But this is something where the EU could pass something where they just say, listen, your data, you get a copy of it, you get to know that.
Yeah, well, or the regulators, right? The FDA could say that, if you want to submit your drug, you have to also submit anonymized data. It's going to go into a database, right? There's a huge amount of opportunity there because there's data from right now, every year, about 1 million patients participate in clinical trials across the board. So if you think about every year, there's 1 million people participating in that level of experiment. And the data are not really being collected. So, but that's where what we focus on is learning from those style of data.
In a country where you have socialized medicine like Canada, let's say, the Canadian government with a pen stroke, Justin Trudeau, and could just say all this is put into an anonymized database, all the data, or just give people a choice. Hey, if you want to get free healthcare, you have to give away some amount of data to the collective good, anonymized, or it could be opt-in. But I think if you're giving socialized medicine, it's not too much to ask that your blood results, which the government paid for, get to be put anonymously. Your name, your approximate region, maybe ethnicity, DNA, whatever. Or some amount of it gets, I got to think this through because it could get a little dystopian if it gets
complicated.
Released.
Yeah.
It does get complicated that the state owns your data.
Yeah.
But there is some trade of services here. So in a commercial country like the United States, it could be, we'll discount your rate if you put it into this pool for future research, or like organ donating, you could just do it out of the goodness of your heart. In a socialized medicine, they could say, listen, we just want everybody in the country to give their blood data to this research. I mean, there could be a way to do it in a very positive way. Is anything like that even being considered these days, or no?
No.
Why is it so obvious to us and not everybody else?
It's
so obvious.
Yeah, it's difficult. I think that there are definitely a handful of countries that have better medical records. Where, if you have a national health system, it's easier to have a national medical record system. But it's still not the case that these are like a repository of people taking part in these kinds of research studies where you have a really much more rich information about those people than you do a normal, like just from your medical records.
All right, everybody. Our friends from Microsoft are here. Tom Davis, a senior director at Microsoft for Startups. How long has Microsoft been working on this cloud that you've now sort of uncovered and offered to founders?
It's been years in the making, so to speak. The evolution of AI has taken many twists and turns in its journey. These large language models have really been the game changer. And that's really thanks to OpenAI and the work that they've done. And it's obviously our partnership there has helped us really get ahead of the game on this. And we're seeing great companies like Perplexity.ai. In 6 months, they've built out an application that has now got millions of users. that wouldn't have been possible in a more traditional way of working. So it's great to see the innovation that startups are able to bring to the table now and not have to make these huge investments in time, resources, and basically cash as well, which is always at a premium when you're starting off your own company.
The Founders Hub that Microsoft provides offers $150,000 in Azure Cloud credits, all the development tools like GitHub and Teams, Office, all that great stuff. You get all that for free. 5 minutes to sign up, 6 figures in benefits. aka.ms/This Week in Startups. Thanks so much, Tom. Tell me, how does your company make money? Because you are a startup, you raised a Series B, I understand. You've done pretty well for yourself here. VCs are placing a big bet on you. What's the business model?
So we actually have a relatively simple to understand business model. Our value proposition for a pharma company is that by working with us, your trial can be months shorter, many months. So it depends a little bit, let's say 6 months to a year shorter. And if you're a pharma company, your patent clock actually starts when you start your clinical trials. So every 6 months shorter or a year shorter, that's an extra 6 months to a year of on-patent sales. So it's billions of dollars in revenue for the pharma company, if the drug's successful. And as we said, that's like 1 in 10. But so how do we do that? Well, the way we're going to do it is we're going to allow these pharma companies to run clinical trials that have smaller control groups than normal trials. So you have fewer patients that you need for your trial. So let's say you need 100 fewer patients in your clinical trial. Well, there's a couple of things. One is that, that again, it might take 6 months to find 100 patients who are willing to participate in your clinical trial. So right there, you've saved a whole bunch of time. But pharma companies also pay about $100,000 per patient in their clinical trials. Yeah.
So that's where that $100 million number comes from. You get 1,000 people in a trial, you're at 100 milli.
Yep. Yeah, exactly.
And the patents are, I think it's pretty standard, 20 years.
20 years.
So you're talking about a couple of year trial. What did you say a
5
trial
years.
Is? 5 years. So you're at 15. If you were to get them that extra year.
Oh, that's just one trial.
That's one trial.
You still have your phase 1. You have your phase 2. You've got your trial.
So what is by the time you get it to market, how many years you got left on the patent?
Probably like 10 or 12.
So you have 10. If you save them 1 year, you get 10% more money.
Yeah, that's right.
Or 10% more time to exploit the drug.
Exactly. Yeah. And not only, that's the capitalist way. We can also frame it and say, well, there's a whole group of patients during that year who needed a drug who now get access to it, right? Because otherwise, if it was you wait another year, say you have, groups of patients in a disease where people are dying, right? If that drug's not available, all of those people are dead. So
I know people with cystic fibrosis, and this is an area where it's particularly acute, and they've made incredible progress. But these drugs are extraordinarily expensive for a very small number of people, and there is some compassionate use of this, but it is really a challenging dynamic. Maybe you could talk about the long tail of diseases and how this should apply, because that does also seem to be something unique. We have the big 4 horsemen, of diabetes and cancer and whatnot, that kill people. Alzheimer's, I think, is in that group. But there's the long tail. So is this going to have a dramatic effect on the long tail as well?
We think that this should be used in every single clinical trial period.
Okay. Yeah.
There are challenges that I would call technical and data challenges to getting there. For all of these small diseases, that also means there's a small amount of data to learn from, right? So if we're talking about Alzheimer's, so many people have Alzheimer's, we can build really, really big data sets. But you start talking about, something like cystic fibrosis is a lot smaller population. And so we still need to have enough data to train a machine learning algorithm. But we are working on that all the time, how we can do better with these small populations. And over the next few years, we want to be able to roll things out across everything. Actually, our ultimate goal right now, the way we do our machine learning is there will be one model per disease. So we have like a model for Alzheimer's, We have a model for ALS. We have a model for multiple sclerosis, like that. We want to build one model for everything. One model for like all human health.
No, that's an extraordinary mission. I mean, this is
very hard, but
it's kind of like AGI versus vertical, right? Like you verticalize cholesterol or heart disease. You know, you need a certain data set for that, but Alzheimer's might be overlap 50%, but not 100%. Am I ballpark correct here? Is that
exactly? You know, that's right now. Yeah, so you get these specialized data sets. We build specialized models, but the whole point of it is, I think that in order for us to get into these smaller disease areas, we want to have something that looks sort of like a foundation model for health. So one of the things we talk about these large foundation models today doing is that they can do either zero shot or few shot learning. And what that means is that they can learn to predict things having seen one example. So instead of having to give it like, we need you a million examples for you to figure it out, we can show, here's one example, what would happen in these next few examples. And so we want to probably be able to build something similar where for patients, even with really rare diseases, you can still figure it out from just a couple of examples.
That's extraordinary. In a way, it's like the foundational models of ChatGPT or Stable Diffusion and some DALL-E and all this stuff. My understanding is people think you're going to be able to fit this on your smartphone. And so the model will eventually be on a chip. And when that happens, that's going to be pretty wild that you're just like you have a Wi-Fi chip or, you know, a graphics chip on your phone or computer. The concept of having an AI chip on there that just guesses the next word in a sentence and it's kind of starting you on third base every time. You could do that for health. Then my Apple Watch might have this built into it and it'd be like, wow, we're seeing something with your heart. We know what you ate. We have your blood sugar level because you have a continuous glucose monitor. It could be like doing stuff in real time. Forget about trials. You could be doing real-time interventions.
Yeah, there's all kinds of stuff that are really interesting. And again, hard problems, but I want to know not just what is happening with me today, but what will happen with me in the future. I want to have something that can predict the state of my health in the future, depending on what I do today. If I change my diet in this way, how will that actually really affect my state of health over time? If I take on this different workout plan, how will that affect my state of health over time? And it's a super duper hard problem, right? You talked about how complex, like the human body has 37 trillion cells in it. It's actually 100 times the number of stars there are in the galaxy.
It's wild.
So it's like a really complicated system. It's actually so complicated, I think that AI is going to be the only way we can tackle it, right? It's too complicated for us to try to build up piece by piece. So I think that AI is really going to be fundamentally the new language of biology in the end. Like we are going to describe biology in 10 or 20 years entirely in terms of like AI algorithms that are learned to understand and tame this complexity. And once you get to that point, the idea of you have your own digital twin that's on your computer that talks about your health, and maybe your doctor also has that same thing. You don't even need to go to the doctor's office anymore. They just pull up your digital twin and they can see what is happening with you today and what's going to happen with you in the future. And they can design treatment plans. Maybe it's even an AI doctor, but I think that's the future. I mean,
you already have this happening again, back to vertical AI versus general AI, which is analogous to what we're talking about here. You already have in x-rays, people are starting to build technology to look at the x-rays or to look at like heart rate monitors over time and just highlight stuff that then goes to a doctor, and that's augmentation. And so what I've been really thinking about in this AI future, because this is moving rapidly, you've been doing this for 6 years. How would you describe the pace we've seen of the past year compared to the decade before?
It's definitely moving faster. It's interesting in like, I think what's happened more is that we finally reached a threshold of utility. So things seem like they are moving really fast when you're near a threshold of utility, even if they're moving slow. Because like if you just stay at a linear line, you just increase by X a little bit every year. But there's some threshold at which you need to pass before people care about it. you will seem like no progress has happened, and all of a sudden you'll pass that threshold and everybody like, wow, amazing progress. And I do kind of think that's where we're at, that the AI research has been pretty steady progress over the past 10 or 15 years to bring us to this point. But it's all of the sudden got good enough that we're willing to use it, right? I mean, if you think about like GPT-3, the API to that was released 3 years ago, right? So it's not like we're in some exponential speed up of like Terminator world, because that was a 3 years waiting period between 3 and 4, right? Yeah. So that's actually not that fast. It's more that what's happened is people have figured out, oh, wow, these models are actually able to solve stuff now, and we can build applications on them. And so now it feels like it's incredibly fast because there's all these applications, because before they weren't useful and now they are. And so it's really more of a cross that threshold of utility than I think a real like speed up in the research. The research is kind of the same.
Yeah, there is something perhaps to humans using it, finding the utility, and then the reinforcement learning, or these GPTs starting, or different language models, different AI instances learning from each other. That also is, once you get humans using it, it's like, well, GPS is really interesting for sending a missile or tracking a plane, but it's also pretty good at finding a bakery or getting an Uber, right? It's like, the street finds its use for technologies, is what William Gibson said. And, it's like, that really feels like what's happening once you put language models into a chat format. It's just, or you start building auto GTPs or plugins. It's like with streets figuring out all kinds of interesting use cases for it. Hey, listen, thanks for doing this work. And on the revenue question, since you saved them that extra year, you just want to take a percentage of that, or take a percentage of how much less people can be in the study? Is that the ultimate goal?
Yeah. So that's why I was saying earlier, the business model is relatively simple. So if you're paying $100,000 per patient and we remove one patient, you should pay us $100,000. If we remove two, $200,000. So we just get paid based on how much smaller we can make your clinical trials. That's our main business model. Or maybe
you split it 50-50, so they get a little savings.
Yeah, we tried to take them, which again, they're getting billions of dollars in additional sales. So they're getting a great deal by working with us. It's an example of our work in clinical trials, I think, is a really unusual example of something that kind of everybody wins from. Because the pharma company, they definitely benefit, right? They can make a huge amount of additional sales. But the patients also very clearly benefit, because you have a smaller control group and you have a faster time to market for the drug.
Got it.
Even the regulators and people benefit from this, because it's a use of AI. Well, actually, we can prove that the clinical trials produce the same scientifically rigorous results. So kind of everybody benefits from this technology. I think that there's going to be a lot more areas in health where this is the case, where technology is just going to totally benefit everybody. I think the difficult part of building in this space is that, it's kind of this legacy conservative industry, and trying to figure out how to get people to trust and adopt new technologies is hard.
Yeah, we have the Wikipedia as an example of a foundational data set, and the DBpedia that's being kind of built off of it. It's really helped train these models. Is there an equivalent in your world? And if not, would that not be something noble for the government to work on? If way of saying, hey, let's find 10,000 people in the United States and give them a battery of tests for their lives, and really get that data set and open source it to the world to learn from.
Mm-hmm. I don't think that there's one. There have been attempts to kind of go in that direction. The UK Biobank is an example of something that kind of starts to look a little bit more like this, which is the NHS's version of this. So exactly that NHS is like, hey, we have a national health system. We could create a big open source data set for everybody. And there is a big open source data set. Verily also, and Google had tried to run something they called Project Baseline. I don't know what its current status is, but the whole idea was enroll 10,000 people into a big observational study and follow them for a bunch of years and collect all this information. And then we'd have this data set to learn from.
That was Verily, right?
Verily, yeah, exactly.
That was Google's Live Forever healthcare thing.
Well, I think you need something to learn from, right? Like kind of what you're saying. So baseline is like, hey, let's collect this data set. Let's build this thing that we could learn from. I don't know what the status of that is, but so there've been a few different options, but I think that I 100% would support the US government trying to build a similar type of data set.
Yeah, the ability to reduce suffering, extend health span. Maybe we don't add years to life, as Peter in his new book has been talking about. Attila, I guess this is how you pronounce his last name. He talks a little bit about health span versus lifespan. Hey, you live the same number of years, but you're skiing in your 70s and 80s or riding bikes in your 90s. It feels like we're on the cusp of something very interesting here. And so just on behalf of humanity, thank you for choosing this for your entrepreneurial journey, and that you're doing God's work. Or if you're an atheist, you're doing humanity's work. So pick whichever you like. No judgments either way. Thanks for coming on the program, and maybe we can catch up in a year and hear how you're doing next year with this.
Yeah, sounds great. Thanks for having me.
All right. Cheers. Thanks for coming on the program.